Hello. How's it going? All right. All right, so we don't have Mark today, which I think means that the list of pull requests probably isn't up to date. Builds that. Let's look. New month. Um, okay, so as far as pull requests go, we don't have an up-to-date list. I think, is there anything that stands out? What's new? There's the file store, object store stuff that I've been working on that we'll talk about here soon. And then, what else? Oh, Radoslav has a patch for Blue Store that marks some interfaces, some members of the interface final, so you avoid the virtual destructor or something like that. I can't remember. But he's pulling that out of his async read branch. I guess we could talk about async reads. Async reads, and then C star. Anything else we should cover? Okay, so the main thing is I'm working on two pull requests that clean out, simplify the object store interface. The first one just unifies sequencer and collection handle, which we should have done a long time ago, probably. And it's sort of a no functional change. And the next one, the important one, kills unreadable mostly. Basically pushes down tracking of which objects have rights affecting them into file store. Because file store is the only implementation that has a sort of asynchronous write so that your read has to wait until the write happens before you can read it back again. It pushes that into file store and then begins the long process of removing all of the weirdness in the OSD that used to handle that. So the write performance benchmarks look good. It looks like the worst case on write is like a 1 to 2%. In my tests, I couldn't really see it on my box, but Radoslav saw a small regression. But general thinking is that's worth it to get rid of all the other stuff. And we'll eliminate callbacks in the OSD and code and it'll simplify things. The part that I forgot was that there's also now a check on every read call to check if there is an in-flight write on that object. And so we have to also benchmark the small reads on NVMe and see what the impact is there. So Radoslav's doing that, I think, today or tomorrow or whatever. It's late today to make sure. I think it'll be fine. It's a hash map lookup, and so it should be okay. But we need to make sure. But that's exciting. That's going to pull out a whole bunch of random. Vastly, the interface cleans up, so there's only like one method now to queue a transaction, and the transaction is applied to the in-memory cache synchronously. So when that call returns, you can read back the result. Although annoying flavors of that are all gone. It does keep around. It doesn't actually remove the callback yet because there are a handful of cases where I think we still need it. there's this OS driver thing that's used by SnapMapper, and also I notice it's used by one other thing. I can't remember. It's used somewhere else too, but basically it just keeps an in-memory set of key value pairs that are in the process of being written, so that when you read them back after a write, it'll use the in-memory copy. And the point there is just to avoid the actual read. And if we get rid of that, then it would block instead of just returning immediately. So I think we're going to keep the callbacks around just for that piece until file store eventually goes away. But they should be rare, and we can make it conditional on whether the backend is asynchronous, probably. Maybe a Blue Store actually also does the same thing. It has to flush the key value updates before you can read them back. So maybe not. But anyway, that's coming. That's exciting. Any questions on that or comments? The other thing going on is Radoslav has this big pull request that adds async read support to Blue Store, and then also changes a bunch of stuff in OSD to make it work. But it's sort of running up against the complicated flow of control through the OSD right now. So I'm kind of thinking that we should wait until we map out what we want to do to restructure, clean that up first.
Yeah, I suppose we could probably wait, but I don't know. What do you think, Radoslav?
What I'm afraid is the current state of the OSD asynchronous infrastructure. We are reusing parts that was written mostly for recovery. In some places, they are simply slow. We are doing a lot of unnecessary work, and I'm afraid we can see an effect where we got some boost from from going asynchronously, even for a random for random reads scenario that is that could be in some situations offset by for instance re-executing context twice. Yep, I would also want to make a bigger cleanup of the stuff before merge.
Mm-hmm.
The typical case is sparse read. It's implemented in master. It's for asynchronous reads, for easy pulls. It's implemented in that way that basically gets all the data, then wraps it in together with header consumed by RBD. It's very, very far away from object store should do. For Blue Store, we have patches bringing sparse read support. All we need to do is to clean up the OSD infrastructure.
That piece seems like something we can do separately, right? Add a sparse read that's unrelated to the async.
It is. It truly is.
Okay. Maybe we should push that forward.
Yeah. On the other hand, I'm afraid that the async read PR is growing big. With mixing it with cleanup, will make it even bigger. It's even harder to review.
Yeah. Yeah, I'm just nervous about merging something that's complicated that's not going to help much, and it's going to make our life harder when we refactor the flow. It's going to be hard enough with all the cache steering, promote, demote, promotion stuff.
In other scenario, maybe we could dissect some commits that will be useful for the great C-star rework. I mean, Bistro.io sharding.
Yeah, I'm kind of thinking that we should try to extract everything that can be extracted from there. and do it separately.
Okay.
Like the view start, the sharding, the read sharding is one thing where I'm not sure it's actually going to help, but we can make it parameterized by a number of read shards. So you can just set it to 1 until it actually helps.
Yep.
And the sparse read we can pull out, and any cleanups and stuff we can do that separately.
Okay, in that scenario, we could the rest of the branch could be joined with the cleanup, with the changes, with the rework of execute context. I would expect that after that, even random reads, not only sequential reads, random reads could be much faster.
Josh, how are you documenting when you're mapping things out? How are you capturing that? Just like a
I'm just doing a
pad
text file for now. I'm just gonna, I mean, I'll put it in a pad
okay.
later once it makes more sense.
Okay. Okay, cool.
By the way, for touching execute context, as you told Sage, it will be very good to have a map of a call part of the call graph that is related to the function we are touching. Making it could be painful. So maybe if we could integrate the Adam Kupczyk's wall clock profiler and to tautology and run a bunch of our tests, maybe we could get something detailed enough to know what we are doing, basically.
Partly what you're doing is that, right, Josh? You're mapping out all the call chains.
Yeah. I guess it's not strictly profiling though. It's just good reading based.
Yeah, I don't know if the profiling part matters that much.
No. The profiling information is a bonus. But what Adam's tool does is simply making a call graph with some annotations related to performance. We don't need to use those annotations. We can go with the graph.
I mean, I think the key thing here is knowing that what all the paths are that lead to execute context, for example, and whether an operation will loop around where it gets submitted multiple times and so on.
Yeah, like all the times it can be put on different wait lists.
Yep. At the moment, I think that Adam's tools capture those informations and then use them to make the final output. But we could use them raw.
Well, gprof will do that. I mean, I guess does it matter? I mean, are we looking for paths that aren't regularly taken and things like that? Because I assume any profiler executing
we need all paths, right?
Find the things which it sees.
We need to
We need to account for all the edge cases that we don't necessarily include in the given test run as well.
Yeah, and I think what I'm kind of imagining is that once you have just the skeleton of the call chains, what we really need to do is write a bunch of annotations that say, like, this is where we prepare the log event, and this is where the version gets decided, and so on, because I think that's the part that's complicated. We need to move all that around, and so that we have a more a simpler flow, and one that will more easily, elegantly compose into all the different combinations we need. Yeah, and the calls down into all the calls into the BG backend and back and so on. Yep. Okay.
Yeah, so I think that the profiling idea could help us verify that we didn't miss some paths, but it wouldn't provide a complete answer.
Okay. So that's one piece. What else is happening? So Kifu's starting on.
He's starting to look at the tame reactor idea. So that's basically a way to communicate between regular threads and C-stars threads, or C-stars reactors. Just being able to queue things into C-star and return results out to the regular threads again.
Okay. Yep, that sounds good. Getting the build.
And, yeah. In case he had also shared some of his thoughts about that on the list now.
Great. Okay. What should we cover now? Anything we should discuss now?
I see Ben England's on the call. Ben, do you have any new results that you would be interested in sharing?
Yeah, I was waiting until you folks were done discussing whatever you normally do because I'm not usually here. But Alex Calhoun and the Perfect Scale team is running RVD tests with BlueStore, and we're hitting a weird result that I was hoping maybe you could give me some ideas on what to look at. Sorry, I don't have like the data like ready to throw up on the screen here. Maybe I could, but the problem is that 64 kb, there's a sudden spike in increase in RVD write throughput with BlueStore, and it's too high. It seems like because we're getting like 500 writes per OSD, which just isn't possible. So like I'm trying to understand what's going on here. And has anybody seen? Go ahead.
It's certainly possible because writes, in theory, you should, in theory on writes, you could get the full bandwidth of the device, right? If you like are perfectly batching them and writing them out sequentially, even if they're small. So it's probably more that for the lower IOs, we're hitting some other effect that's preventing us from going as fast as we're going with 64.
Okay, so Alex noticed there was this parameter called min allocation size.
Yeah, and that's probably set at 64K, right?
Yeah.
Yeah, that's why.
Oh.
So writes below that. So once you hit 64K, the write is going to be just written to a new area of disk. It's like copy and write type behavior. It'll just write, and then all those will just be laid out sequentially, and so you'll just go fast. Below that, you're overwriting. If you're overwriting existing data, then it has to overwrite a previous allocation, and so it's going to do a data journal, and then it's going to asynchronously go and update, overwrite the previous allocation. And so that's why it's slower below min alloc size.
All right. I'm not sure I'm totally following this because if you're doing 64K case, it's still these are random IOs and you pre-allocate it. We write out like zeros or whatever. So go ahead.
Yeah, but because it's above that threshold, we just allocate new space. So even though it's previous allocated, there's old data. We just allocate new space and we write the data to a new place. And then once that's stable, then we throw out the old allocation.
Okay. Yes, that would explain it then. All right.
Yeah. There are things that you can do to get similar behavior for. No, never mind. I take it back. Yeah, once you're below that, then you go into the right behind mode.
Okay, so let me ask a stupid question then. Why was that number 64K chosen?
Why did we choose 64K? can't remember.
Is it something
I think
like
we
a
looked.
It's where the
I
curves.
think we looked at the performance curve with it very high and very low, and we basically looked at where they met, and then 64 seemed like the crossover, I think, but I can't quite remember.
So you did look at the different values, and that seemed to be the best one.
I can't remember exactly.
All right, maybe we'll play with it then. All right.
Yeah.
So
Try
I
playing
just
with
wanted
it,
to. I was just picking your brains about what you knew about it. That's all.
Yeah.
So all right, that's it. That's basically all I had for today.
Okay. Does this? I thought you were seeing other results that just weren't as good as you expected them to be with Blue Store. I'm wondering if we got to the bottom of that.
I think we did. I'm still looking. I've got to sit down with him and look at his data again. But I think there were some problems with memory management where we had done some things that didn't make sense. So we'll get back to you on that.
Okay, that's good. Cool. Okay.
Thanks a lot.
Yeah, no problem. Yeah, that's all I have. Is there anything else we should take the time to talk about that's on people's minds? Oh, one thing. I was talking to Alan Samuels the other day, and he's going to be in Beijing with us. And we were talking about carving out a piece of time to sit down and just work through the high-level design of what the new object store implementation will look like for NVMe. Just like whiteboard it out, try to like come to some consensus on what we want to plan to build. It'll be, I think the thinking is that the design is going to have, it's going to be relatively independent of what the specifics of how we're using G-star and so on are. We'll just, because we're just assuming that it's going to be, features based and whatever, but that like the on-disk layout and the general behavior of that backend will be relatively independent. But I guess my feeling is I'd like to get those design discussions started sooner rather than later, so that we sort of think about them thoroughly before we start writing a whole lot of code. What do you guys think?
Yeah, that sounds like a good idea to me. I think the one thing we want to consider is in the kind of end state for the C-star work, are we going to be having like one object store per shard, or one for more than one?
Yeah, I think we can't, because unless we're like replicating all the OSD storage and so on. But the main problem that I keep running up against is the snap mapper is an index of objects or index of clone objects by snap ID, and it doesn't shard because it's updated as part of a transaction for a placement group, and the shard that a particular object belongs to will change when you split a PG.
Right.
Because we're sharding based on the PG ID and not like units globally. Maybe
we need to go back and reconsider then making each shard a different logical OSD, and but still sharing like the OSD map cache and what else we can there.
Yeah.
I think more to the point though, the allocator needs to be aware how much free space is available. And unless you want to just split the drive up 16 ways, then it needs to be a thing for the whole device.
Yeah. The devices have this notion of namespaces, so it is an elastic thing, is my understanding. But we have to make sure that that actually works. That said, yeah, the problem with the thing I worry about with breaking the if we shard the actual device, so hopefully it's not 16, hopefully it's more like 4, right? If we need 16 cores to keep a NVMe busy, then we're in trouble. But if that's the case, then if it's one OSD and you split a PG and the PG jumps to a different shard, is that the same thing as if you have 4 OSDs and you split, then that PG is going to move to another? It's going to move to another OSD no matter what, I guess, right? So it doesn't matter.
Right.
It's going to temporarily move to another shard on the same OSD, and then later you're going to move it somewhere else, which is sort of a pointless. Yeah. Okay. So yeah, maybe that makes sense, because actually once we have the multiplexing in the messenger, then it will be sort of the same.
Yeah, it'd be pretty straightforward to get the OSD structures duplicated.
Yeah.
Hopefully.
But
so back to the question of like multiple devices or one device for object store. You think that we will end up needing more than one core to drive a device? Because that would imply some kind of coordination.
I don't know. I mean, right now we do, right? Right now we need many cores to keep an NVMe busy. But I worry. Yeah, I don't know. I don't know how fast we can get it, right?
Mm-hmm.
Like if you have a box with I don't know, how many cores do we need to keep one NVMe busy right now?
Well, it seems like we get performance benefits by splitting them up at least 4 ways, if not more than that. So.
Yeah, and it's probably like 3 or 4 cores per. I mean, it's probably need like 16 cores. I don't know how many. I don't know. But the thing is, the devices are going to get faster too, right?
Yeah.
So, well, they're going to get faster and they're going to get bigger. So it sort of goes both ways. Goes both ways. And it seems not like it's
efficient. If that namespacing is like an efficient way of coordinating within the device layer, then that would be nice. But what were you gonna say, Ben?
I was just gonna comment that I've been running on Skylake with like 60 some cores, and we burned up just about all of them on running with 4 NVMe SSDs, and some of that is, got to sort out how much is really the device and how much is really networking and how much is the context switching that we're doing. This is Luminous. And but do you think that one of the questions I had for you is, do you think that like networking is a piece of this, where just the act of having to copy data in and out of the kernel and all that sort of thing is?
Yeah, it's certainly a piece. Like we're not doing any easier. We're doing plenty of copies like between when we get off network and when we write the disk.
Yeah,
that's the one thing we want to eliminate.
So I mean, is the answer for that like basically going to like a DPDK or RDMA or some alternative transport?
Yeah, exactly.
Yeah.
And are we looking at that like has anybody measured sort of the answer to that question, how many cores per SSD with those transports? Or do we not need to because we already know from profiling that it's somewhere else?
I'm not sure what kinds of things Mark's done lately.
I wonder if the answer to that question is to talk to the SPDK folks and with like their SPDK iSCSI, for example, where they have DPDK, SPDK, iSCSI server, and what their CPO overhead is, and that is sort of a lower bound.
Okay.
Like that's a comparatively simple protocol.
Yeah, that sounds like a good plan.
Is anybody from Intel on here? Let's see. Doesn't look like it. No.
So, do you have any documentation about that namespacing in the NVMe stage? Because what that sounds like is for virtual, like pass through of virtualized machines, and I could definitely see that coming with a performance hit inside the drive because it's probably tracking extra stuff.
I mean, you're always using a namespace, right? It's the sort of NVMe equivalent of a partition, and I think it's just built into the because internally the drive is doing its own log structure thing, and so I think it's just built into all that mapping layer that maps the logical block offset into the physical pages. It's just part of that whole implementation. So I wouldn't expect there'd be any overhead, actually, but I'm not really sure. I mean, I know that when your like device has an N1 and 2 or whatever, like when you're actually using the device, you're using a namespace. I'm not sure. I don't think you have to use it in order to get the performance because you can use multiple queues on the same namespace or on multiple namespaces, so it's not required. But I don't know. It's part of the NVMe spec. So if you go read the NVMe spec, it's. Let me find it. Let's see, 1.3. It's a corrupt PDF. That's awesome. Let's try the one that isn't. No, maybe it's my browser. Yeah, I don't know. I mean, you can go read the spec.
I mean, the spec doesn't tell you. We need to talk to hardware vendors and see if they like their reaction to if we say we want to use it.
If you want to use the namespaces.
Yeah.
Yeah.
I mean, there are lots of things in specs that work.
Yeah, it shouldn't be used.
They don't expect anyone to actually make use of it, and so it's thoroughly slow or whatever.
Yeah, we can double check. I'm pretty sure this is something that's meant to be used. And I suspect, for example, that the iSCSI thing is each iSCSI target is one of those namespaces. It's sort of the logical partition-y thing. But yeah, who could I book?
Okay, well, but for instance, when I'm Googling for this, then right now the creation and configuration of namespaces is vendor specific, so it's not very well fleshed out, I think.
Okay. Yeah, I never used it.
Yeah. And my other concern is that if we do split it up into namespaces, then that means that we actually need them to be the same size. Which would be another thing to balance.
Yeah. Yeah, I guess I'm not sure that's really the path we want to take, but it's certainly one that we should consider because that might solve a bunch of problems. Yeah, this is sort of my lingering concern with how well we can shard, because ideally, if you have multiple shards and they're doing transaction commits, it'd be nice if they were like using independent queues on the device and could like commit independently instead of having to go through the same log or something, having any shared data structures there.
Right.
But the snap mapper index key updates are sort of like the wrench that's going to make that hard, because They're non-overlapping, right? They're not. They're always working on non-overlapping keys because it's
So
sharded.
there's different PGs.
But it means that like if you're doing a read, you might need to like consult all shards. Or you have to make sure all shards are committed or something. I don't know.
Yeah.
It'd be weird. They're not totally independent storage structures. But maybe that's what we want anyway, though, because maybe the in-flight write process and the journal is all sharded, but on read, your view of what's committed is always a shared read-only type view. Because again, data will migrate between shards when you split.
Yeah, only if we're running more than one shard per OSD.
Yeah.
If we get like, what's the benefit of doing that? I guess
you can change it, right?
What do you mean?
The number of shards becomes a runtime option, as opposed to like an enshrined on disk thing, where if you like made a bad decision, you just can't go faster because you have the wrong sharding. Like if the OSD can consume no more than one core ever, then that feels dangerous.
I mean, it could be the same process, but with multiple. Right.
Yeah, but I mean, if it's part of the on-disk layout, right? Determined at make a fast time.
Yeah.
Yeah. It seems like it might come down to when we're designing the implementation of that backend, whether it matters, because all the other stuff doesn't matter, right? All the other stuff we can reshard at any time, like just restart the OSD with a different number of shards, and we can divvy up the PGs differently. It's only where it like meets the on-disk layout that there's potentially a persistence problem.
So how are you thinking that might be, that we keep the shards independent on the disk? I mean, like, because they still need to, each core still needs to talk to the NVMe device. So
yeah.
Or,
but they could have independent journals. So when they commit a transaction for their portion of the data set, they would just write data into their journal without having to worry about whether they're racing with the write on another shard.
Yeah, but if you're just worried about the journaling, then we can, like, you can, it has to be a little more complicated than just the config option, but you can have a thing where they read in the journals and write them out into the appropriate new number.
Yeah. Yep. Yeah. Hopefully. So, I mean, the thing with the log structure is that the whole file layout is the journal, right? So it needs to be, in order to be able to reshard without like rewriting all the data, it has to be the case that you can read data from journals committed by other shards. Which,
well,
I think we should be able to do without too much trouble, but we just have to make sure we.
The other option would be resharding by recreating the whole set of objects on disk, right? Say destroy this OSD, recreate it with a new sharding policy.
Yeah, that would be.
If you're not recreating the thing, then it's really about the ownership. So you can go through and reassign the ownership of the different block regions to different shards, and maybe they are trying to modify nearby blocks at the same time, and so it slows things down inside the drive briefly when they do a delete. But
I mean, it'll be mixed because you'll have these 12 PGs are in shard 1, and then we split, and now you have 11 and a half PGs in shard 1, and a half of that PG is now in shard 2. So a given log segment, I don't think it's going to be much of a problem because the whole point of the log structure is that it's read-only. Once it's written, it's read-only, and so the sharing stuff is easy to deal with. But it's just something we need to think about.
Okay.
No.
So I guess I'll be real curious to hear what the hardware vendors think about this kind of
around namespaces
and the SPDK and DPDK folks, what their CPU overhead is per device.
Yeah. I'll ask Tushard until see what. Okay. Well, I'll put something on our tentative schedule to talk about this stuff on Monday, I guess. Okay. Anything else?
mdconfig t, get val of it.
Oh, yes, it sucks.
And it was used in some critical I/O paths. At the moment, there is a PR ongoing that switch back to the legacy infrastructure. But the open question is, how do we want to address it in the future? Yesterday, I started sketching some very small and stupid utility class for provide caching for a particular configurable, while still observing for changes. But not sure whether it's the direction we want to follow. Maybe just the legacy is the option. Not sure.
I think so that the approach I've been taking for now is just keeping or reverting to the legacy stuff if it matters, because we don't have a better solution, and the legacy thing is not that bad. As far as making something better, the fundamental reason why it is this way is because we need to make sure the config update is atomic. And so I think there are two options. We can make a trivial wrapper thing like you're talking about that just does the observer but has a cache value. That is, as long as it's if it's just like an integer value or something, or it's a single word, then it's fine, at least on 64-bit processors. Or if we're paranoid about it, we can make a standard atomic wrapper around it. So it's an atomic wrapper around it. And so you're reading an atomic instead of reading a native.
For insert, for typical cases, it should be quite cheap, I would say.
Yeah, I think does anybody know what's the difference between reading an atomic int and reading an int, or I guess an int64, as the case may be? Like, is it the same?
I guess
there'll be potential fencing operations, right? But those are
depending on architecture.
Like lock the CPU memory buses to make sure that no one else is accessing that region of memory.
Not on it doesn't. It wouldn't lock it. It would make sure that there'd be a barrier to make sure that
but on
other CPUs have flushed their writes or something, right? But wouldn't it? Yeah.
Well, it's not.
I'm not sure.
Grabbing them inappropriately.
I'm not sure, but on x86, just reading, the impact on just reading atomic is negligible.
There's still a way to there's still a slow and a fast case depending on whether there's a fence that intersects it, right? But still, it's going to be faster than what we're doing now. But we need it. We need a general approach though. We need to. So I like there's a whole thread of ideas that Radoslav and Adam and I have been talking about. We should put it somewhere, but we should do a group of them together. Mm-hmm. Adam actually has the idea of maybe a sort of a gperf like string stub thing also to clean up string things. I don't know if we need that, but there's lots of string ones.
Yeah, the string ones are harder because they you need updates that are you can't atomically update a standard string without locking, right? unless what you're actually accessing is like a const car or something.
Yeah, we're talking about something about the other side of it. So
my idea was using something gperf-like for the keys rather than for the values.
Not for the values, but for making string comparisons cheap, converting them essentially into integer.
Yeah.
Guys, I am afraid we have two issues at the moment. First one is that the get value takes exclusive lock, even for reads. So this means it sucks when it comes to parallelism. The second source of the pain is get value being slow. I guess it's slow, not because of the cost of comparison per se. It's being slow because of fetching memory that is required to make the comparisons. Whether we have ints or strings doesn't truly matter if they are available to CPU.
It's and it's traversing. It's looking up the item in an RB tree, right? It's using the red-black tree indexed by string. It has to look up the value or the key.
And moreover, we are doing that by std string. Yet another memory and direction.
I think have we
that's why gperf could help. But unordered map could help, as you pointed out in this thread.
Sorry, what'd you say, Greg?
Have we considered just not using the mdconfig tstruct anymore? I mean keeping it, but like just set up observers. There's
right. So I think that's what we're talking about here. So we're talking about, so the problem is that to set up an observer for every random thing that you want to set is like 20 lines of boilerplate, and it's super tedious and it's easy to get wrong. So what we want is a class where you just basically declare it and you give it into the constructor the thing that you're observing, and it instantiates the observer for you, right?
Okay,
so
but
I think what we want.
Atomic reads then at that point.
What's that?
Why are we talking about atomic reads?
Well, I think we need a couple different variants. So one variant of that would be the unsafe version that you could use on like a uint64 or something like that, and it would just do basically what the legacy code does, where it just writes into it unsafely, and we read through it unsafely, and we just rely on the processor's word updates being atomic. And then we could have a version of that stores into a standard atomic wrapper around the type, where the observer writes into the atomic, and then when you want to read the value, you read from the atomic. And then we probably have to have one for string. I don't know. String is hard because then you have to have like a const car or something.
Maybe not so hard. Guys, can mdconfig t, can its internal structures, the maps of the schema map, the maps of values, can they change after loading? If not, we can store a reference to it in the wrapper. Not copy of value, just a pointer. uint64 always.
Yeah, but then you turn it into like an RCU type thing. So that would be another approach for string. So you could have a pointer to the string, but then you have to keep around all the old values for some period of time or forever. So that threads dereferencing an old pointer don't. You have to do the whole RCU thing, right?
It's a trade-off it's a trade-off. Just speed up for.
Yeah, we shouldn't. Adam and I have to drop for another meeting, but with this, I just wanted to say we should be attacking this one. I mean, I'm glad that we brought this up. We should be attacking it as a. I also sort of there's maybe observe for a group of them that or some way to get to the whole.
Yeah.
Set up anyway, something I think we need to do.
I think the string one is kind of a red herring because I don't think that the ones that look at strings are tend to be performance sensitive. Because if you're comparing a string in a hot path, then you're doing it wrong anyway. So I would suggest, Adam, just focusing on, or not Adam, Radislav, or whoever's doing this, to focus on a simple wrapper class that makes it really easy to set up observers for the other types like bool and int.
That's
And
the idea.
I would make an unsafe variant and an atomic variant, just for the sake of comparison, and we can, or start with
Sure.
one and
The instance of such class would be static in typical case, I think. So we can have some troubles because of that. I'm not sure about the registering of observer from context.
And why would it have to be static? I think you would instantiate the when you instantiate the little thing, it will, in its constructor, it will register the observer, and in its destructor, it will deregister the observer.
Yes, and
Right.
we want to have those parts being executed as rarely as possible. Making static is a way to do that, but not only way to do that.
I would imagine that these would be members of like the blue store class or something, like things that are instantiated very rarely. Like you wouldn't want to do this. Yeah, exactly.
But
you wouldn't want to do this on a short-lived class.
That's another approach.
That's exactly how we would use it, and you're right.
Yep, that's another approach. The most I was thinking about something that it's so easy to apply that it doesn't require you to go to a header file to add a member to a class.
Exactly.
Just one liner. That
like
could
unsafe,
do it that way. But I'm not sure whether it's possible. We'll try.
Like that. You declare the thing, and then you would declare the observer, or maybe the observer has a member that is the thing. That's probably what you want to do. Actually, you want to have like, the observer has a dot value or something.
Ultimately, the changing from get value to the cached variant will be one liner. That's the goal, I think.
Yeah.
Nobody wants to poke too much with declarations. Just exchange one single line. Done.
Yep. You declare it, and then you change all the gconf arrow whatever's to use it instead. Yep. Okay.
Is this going to be useful for anything except for like timeout values?
Every config option that isn't a string.
Well, no, because I mean bunches of them are like the number of shards or the thing we want to hash on or stuff that.
Yeah, things that can't be changed at runtime. So this would be everything that you can change at runtime.
You change at runtime, but that you need to do a lot more than just swapping a.
Yeah. So those ones, if there's actual work that you have to do, then you have to do all the work of setting up the observer and so on. But there are like a long list of things that aren't.
That if it's atomic based or whatever, then it needs to be something that can change while something else is happening, even if.
Yeah.
Whereas, like, if it's grabbing a lock, it can happen in between operations, but not during an operation, because that makes sense. I think
so if it's delicate, then you have to do the old thing.
Well, I mean, you could also have one of these that takes a lock before it changes it. Like you pass it a lock.
Yeah. Yeah, I could do that too.
Just seems safer to me, but maybe that's not the way we want to go.
Yeah, that's not a bad idea, because there are cases where you take the lock to update it, but you don't have to do anything when you're reading it because you probably already had the lock.
Yeah.
But they're definitely, that'd be a useful variant too. Okay.
Because because could you imagine like someone gets unlucky and manages to change the timeout value in between it being dereferenced in a single tick function or something?
Yeah, it'd be annoying. There are lots of those. All right.
Yeah.
Sounds good. Yeah, it'll be nice to have a better preferred way or whatever, the right way to do it. All right. Anything else? Okey doke. Thanks, everyone.
You know.
Have a good one.
See you.
Thanks. See you. Bye.